Morning.
Morning.
It's Sunday at 10 a.m.
10 minutes last one. Give us a break.
Yeah. Actually, I thought there would be like 6 people out here, like people I know personally and really hardcore Unix nerds. So I appreciate you all coming. I'm Stuart McMurray. I'm a red teamer at IronNet. Also, I'm another one of those hardcore Unix nerds up at 10 a.m. for a Unix talk. My wife said I had to come to this one. So, there's Twitter. One thing I didn't do was put a lot of friendly background information on a lot of the technical concepts in the slides because I got like 20 minutes to talk, and I wrote a half-hour, 40-minute presentation, it turns out. So please feel free to hit me up on Twitter and ask any questions you might have afterwards of like long technical nature. A lot of the code is on GitHub. If not all of it's on GitHub, so there's that. And we'll be talking about Red Hat. We'll be talking about systemd. I'm affiliated with neither of those. My apologies to them as we go through the talk talking about systemd. And the obligatory, this talk does not reflect the views of my employer, any past, present, or future employers. Also, please don't do illegal things. And when somebody does catch you, please don't tell them I taught you how to do it. So a bit of a background to how this talk came about. I was red cell for a local-ish university CCDC team. CCDC is the Collegiate Cyber Defense Competition. It's a bunch of college kids defending a network and a bunch of local professionals undefending the network. It was a school for kind of the older returning to school crowd, and they realized that if you want to catch malware, the easiest way is just to watch network traffic. And they didn't have a really good way to do that except netstat. So they did. And in particular, I had one person running netstat peanut in a loop. Like, I was watching command and just up arrow enter. So I found out that I couldn't use TCP, and I couldn't use UDP, and I couldn't use a raw socket. So if anybody's interested, there's a collection of malware I wrote over like 4 days for these practices, but I had to use something that wasn't visible in netstat. And I came up with 2 options: DNS, which is technically, but it goes away really quick, so nobody will actually see it, and using libpcap, which on Linux is a packet socket. And that was not visible in netstat. It is in SS with a 0 flag. There is a DNS tool I wrote, if you'd like to look at that, and it works pretty good for CCDC at least. So I wrote this thing called pcapnock, and what it does is just watches the wire, watches traffic through an interface, and looks for a pattern. It'll look for either command and command.
Hi folks, I'm Geek here. Unfortunately, audio drops out because we had a technical glitch, but it resumes about 3 minutes and 19 seconds in. Sorry for the problems.
There's a syscontrol you might have to turn off. SE Linux is the bane of Injection's existence, so you might have to turn that off, or set it to permissive so that if something does happen while you're on an op, your clients can at least say, hey, we saw it. Turn it on again when you're done, maybe. So then once you're injected, you have to find a process that can do whatever you want to do. So in my case, it was pcap. But if there's anything that's restricting file system access or network access or what have you, your victim process does actually have to have the ability to do what you're doing, because you're just adding code to a process at that point. It's a good thing if the process is well-coded and stable and long-running and isn't going to oops, and you're not going to oops it. And if you do oops the process, it's good that if it dies, it's not really that bad. Try not to do that, of course. So good candidates for injection: syslogd. Syslogd does network stuff, especially with UDP, which is maybe less scrutinized, and it's up most of the time. Crondy makes a lot of child processes, so if you're going to do a lot of fork and exec or the equivalent, it's a good candidate there. NTPD does stuff on the network. Nobody really notices if it dies. Journald is another one. It's fairly new, part of systemd. Nobody's quite sure how it works, and it looks a little funny if you're used to old school Unix daemons, so it's not, and it's always there, and it turns out to be really great for injection. Possibly the worst candidate, given the above criteria, is systemd. It does have permissions to do some things. The rest is maybe a discussion for another day. So the easy answer to injection is just let's get GDB to ask something to inject for us. GDB will attach to a process. You say, here's a library. Please DL open it. And the process is like, yeah, sure. GDB will set all your registers back. It'll set your stack pointer back, and you don't have to worry about it. And writing the library itself is pretty simple. So you take your normal function, your normal main function. You change from int main to a constructor. And you don't really get return values like you do with main. There's no calling back to the shell to see, hey, what did this return? Also, you don't get argv, so that's kind of a thought. And then it's generally a good idea to spawn a thread after you've injected. You don't really want to block main, unless you do, but probably not. Compiling in a library is pretty much the same as compiling any other binary, but position independent code and shared is what you need to do there, and give it some friendly name that won't look strange if somebody dumps the memory maps. We'll see that later. And then just ask, hey, that's cool. How do I get rid of this? I don't get rid of this. And we'll just ask, this is a GDB command. It says, hey, please call libc's DLOpen to inject it. It's easier to call libc DLOpen mode than libc because you don't have to worry about libdl being linked in. One more thing that cannot be overstated is to test well. Debugging on target is not really what you want to do, and this goes wrong a lot. So, quick demo of what this looks like. We'll just inject a simple hello world. So, compile our binary real quick. Notice can we see this? Sort of. Yeah, might need to link in threads. It's okay, you can link things into a library to link into a process. Put it on target. Also put GDB on target. There's no good way to know if the GDB on target is, if there is one, or if it'll be the right one. Or just check, or, Gun on the box. It's worth noting at this point, two things. Number one, we're sort of throwing OPSEC out the window with all this, so hopefully you have better ways to do most of what I'm doing. And number two, on the latest version of CentOS, you get a nice little web console to do your bidding. So you don't need to SSH in. Found that out about Wednesday, I think. So we'll need to do most of this as root. Is that a question for gents in the back? Is that visible, or you need it bigger? We got it visible. All right, so we'll write our output to hello. Injecting into a process, you get the process's standard out, whatever that is. That you probably don't want to gum up because somebody's probably using it, or it's dev null, so that's not helpful. So we'll write to file name hello. We'll tail it in the background so we can see what's going on. There we go. And here is the injected command. Again, gents in the back, is that too low on the screen, or are we good? Dude, there's like 3 of them awake. That's awesome. So here's our GDB we put up there. Notice we're in temp. Batch is a handy thing so that it'll just run the commands and exit. Tell it to put it in PID1, which is systemd or init. And this is that same command. Just tell it to eval the command and print our output. And by evaling it, it has just a nice side effect of running our malware. There we go. That's normal systemd output. Before we look at the bits on the bottom, that's what libc DLOpen mode gave us back. It's a void pointer, and like most things in libc that return a void pointer, if it's null, it's a problem. This is not null, obviously. Also, we see that we have a new thread, and my malware it'll print out a hello world message to that file. But notice the thread started before we got the return value, so there's a bit of a race condition there. Also, systemd seg faults. I have not yet figured out why or where, and the output's not very helpful. But systemd will still work, still be able to use the box, reboot it, spawn processes, so that'll log, by the way, as will the SE Linux permissive thing and everything you do there. We're nice guys. So, just because. So here we go. So we removed the shared object file. And then we'll dump the memory map. So for the blue guys, this is a way you can tell, post-exploitation, post-implantation, you're kind of hosed at this point, actually. But at least you have a nice way of telling that you're hosed, especially if you see deleted here. So also, you really shouldn't have shared objects loaded out of temp. And there's no real requirement that this end in .so. I can end this dot whatever I want. There we go. So that's what that looked like. The hello happened. Of course, it gummed up the terminal because we're tailing something in the background. But we did have our shell injection. So that's shell injection in a nutshell. Or, excuse me, process injection in a nutshell. Now we have to do this with systemd, which gets a little weirder. Systemd is not quite as easy as it looks. It sometimes starts processes, and when it forks processes, before it execs, but when it forks, it gets a copy of your library. So if you just happen to lose a race condition, you're doing something like pcapnock does, where you send it a packet and calls you back, you may well get a couple of callbacks, or like 20, which happens too. Simple solution there is just test if you're running in systemd, because PID will always be one. If you're injecting into another process, you'll have to probably find the PID and compile it into your malware. Sometimes you do actually get debugging, like you do get standard error or something. And I want to say one of the systemds months ago I was injecting to, like wrote it to the log files, like journal D logs. Simple solution there. And you have like error warn things you can use to exit a program. I wrote a debug. Just wrap it in ifdefs. Then don't compile it with debug information when you're executing on target, and you're good. Another thing I found is that I just exported all the symbols in my library, which is normal writing a library. You want most of that to be used. And I was not particularly careful how I did it. And started seeing some strange things. So it's like, hey, just in case, let's hide all our symbols. So add that to your GCC line. It'll tell the linker not to export those symbols. And the last thing, PCAP specific, is if you listen on the any interface. Listen on the any interface, which exists on Linux and I think FreeBSD. It works pretty well, except you also get loopback, and there may be a lot of traffic on loopback if they're doing things with Docker or what have you. And then some non-Linux boxes, not that you can inject into systemd, not on Linux, but some non-Linux boxes don't have the any pseudo interface. Solution there, use pcap find all devs to find all the devs and just spawn a whole bunch more threads. All right, so we have malware that's running. We have malware that works in systemd, and we can inject it while the system's live. And if we get lucky, the system will even reboot and become live again. So let's get this working now after a reboot. Bit of persistence. And that's in CCDC land, what we'd see is a bunch of kids would do things like, reboot a box every few minutes, or like, I think the red team's on this box, reboot. So it works. It's not very realistic. I'm not sure how many people reboot all of their DNS infrastructure every 5 minutes, but we keep malware off. So there's that, some malware, except maybe persistent malware. So Linux gives us a nice injector by default. LDSO preload is there to preload a library. So when the linker maps a library or a binary into memory, it orders the libraries in the order of where you should start looking for symbols. Well, you can say, hey, put ours at the top. And this is not a new trick by any means. You usually use it to hook functions, like you'll hook the accept function and say, hey, if we get a TCP connection from this specific source port, don't do whatever we normally do, give us a shell. So we'll just use it in more or less the same way, except we have that constructor thing going on. So our function will run, thank you, before main. Ooh, got 10 minutes left. All right, so this works nicely on Linux, works on FreeBSD. Does not work on OpenBSD. You can do it on Solaris-ish using the LD preload environment variable, which works just about everywhere anyways. You can use it also to start a program with a library preloaded. Simple solution, drop your library to disk, put it in a file, put the name in a file, it'll inject. So a few problems that we ran into. SE Linux really doesn't like threads. So systemd starts, sets the SE Linux context, goes about its merry way. If you do systemd starts, your malware starts, spawns a bunch of threads, then SE Linux context is trying to be set. Well, SE Linux will be like, no. And systemd is like, oh, function failed, I give up. So something like this doesn't quite work as well as you'd hope. So I had an idea. Well, let's just wait before we start a thread. It's kind of crude. We'll just inject once systemd has been going a couple minutes, then we'll start a thread. Hopefully set the context by then. It's not a foolproof way to go, but it'll work. So a couple ideas. We'll just wait. Put this in the top of the function, the constructor function, which would have worked if it didn't block main. Actually, it didn't start main, keep main from starting. So next idea I had, it was a great idea. I would just hook every signal handler. At some point, systemd will get a signal, and my code will start. I'll make sure it doesn't, start it eventually, make sure that a couple minutes has passed. Turns out systemd actually uses its signal handlers. So that was maybe not the best idea. And then I like to think that somebody in systemd thought about this ahead of time, and they wrote this function, manager setup signals, to reset all the signal handlers. Another idea, I would hook the clock get time function, and this is more of the old school DLSim hook a function method. And I did, and I had this function start after delay, which would start after delay, make sure we're in PID 1, return the real clock get time. That happened. So quick thing I learned there is to export only the symbols I need. I couldn't export none of them because I did actually need the constructor function and clock get time. Init is what is called before main with the constructor function actually starts. And you just write a version script, put it there. Man, if anybody knows how to get rid of this, can somebody hit me up on Twitter? That'd be awesome. I Googled for an hour last night. The little black bar down here. Yeah, it's a Google Slides thing. And so while I was hooking that, this happened at 10 in the morning after all night of fiddling with this. And then I could either systemd injection or I could SSH. And I was like, oh, I got this working. Systemd is up, the box reboots, I get my callbacks. And I was like, hey, I wonder what this looks like. And I tried to SSH in, and SSH, being an OpenBSD thing, does the whole privsep deal where it spawns a child process that can do nothing but do math. And you can't DLSim either, so it crashes, and then SSHD doesn't actually let you in. Next idea, I would just implement a function that I could hook, but not have to do anything real with it. So memsure, which just searches for a byte in a large amount of bytes. I hooked that. I just opened the systemd source, and it was like, hey, what's a function that'll be called a lot? It really helps if the function is actually called, which it wasn't. So, oops. So it's the same idea. Like, hey, if we're in systemd after some delay, we'll start. Otherwise, we'll just copy paste code. OpenBSD code for a lot of this is really simple and clean and permissively licensed. So I came up with almost the same thing, strlen instead, string length. And this is almost exactly what the function looks like in the code, squished vertically. But same idea. It will start after delay. And then this is all that strlen is. So it's, whether it's my code or Linux's code, it's going to be the same. It's going to have the same effect. So that start after delay thing we've been seeing in yellow the whole time. What it does is it takes proc uptime, which is a little file that has the uptime of your box in seconds and I think the idle time. And the first time the function's called, it takes this number and is like, this is when I started. And then every time it's called again, so every time systemd calls strlen, it checks this to see if 2 minutes has passed. Which is cool. And at first I was just like, hey, when this is 120, let's go. And by the way, don't use strlen to do that if you're hooking strlen, because then you have strlen calling strlen and it doesn't work. Yeah, basically. So guard all the above with the mutex. It turns out systemd does make threads that call strlen. So race conditions are everywhere. Mutex has solved them. Then there was this one minor issue that I had, and I did not have this several months ago when I was putting this together, and I did have this several days ago when I was making the demos with the latest version of CentOS, and that is SE Linux now doesn't like pcap much. And you can't just cheat and open the file in sysfs and write a 0 to it because you get an exception or an access error. So the answer is just call sendinforce and ask it to open it, and that's totally cool. Good job, systemd. Good job, SE Linux. You tried. So, damn it. Go away. Those 4 functions, they're not Linux library functions. I think a couple of them have been implemented. They can get you around this sort of stuff. They can say, hey, let's not actually, even though SE Linux says maybe, let's not actually let them. So I got it working, and this is what it looks like. It's a different way to put a file on target. It works. So we get on the victim box. I think I assume GDB on here anyways. We'll need to be root. You need to set the execute bit in libraries for them to be loadable into a process. If they're read-only and not execute, or read and not execute, injection won't actually work. So we'll put ourselves in LDSO preload, and we'll spawn a sleep just to make sure that we have injected, because with LDSO preload, anything that starts will have the binary, or the library preloaded. Yep, so we do actually have libpcap or libpcap knock in sleep. Cool. Don't do that, like, just because you've implanted a box. Wait for it to happen. Rebooting. Much like a cooking show, we're not going to wait 5 minutes. This is a cooking show 5 minutes. Like, hey, we put it in the oven, ding, we're done. So 5 minutes has passed. We'll background a wait and a send our message to give a callback because I don't have tabs to play with. It's the downside of Eskinema. We'll wait for our callback. And there we go. Another cooking show 10 seconds has passed. And we got a connection from the victim box. First thing we'll do, we'll see if we loaded into systemd. Loaded into systemd just fine. See what else we loaded into. We loaded into everything else just fine. So we got our execution. A couple little debugging tricks I came across that were very helpful. Starting a background process like free sleep 1 will just print text to dev null or loop every second. Gives you a nice little something to inject into. And free loads libdl, which wraps libc's DL open. So you get the nice friendly DL open, which means then when things go sideways, you can call DL error and get the what happens. Usually it's a file doesn't exist sort of deal. Another thing that is hard to figure out is what your library is actually doing. You can hook up a debugger to systemd, but it's It's not the easiest thing to do, not the safest thing to do. Easy answer is just reopen standard error. Put standard error in a file and just tail it in the background when things happen. Even like, hey, I got here, it works. So TLDR, write your malware as a library, take it from main to a constructor. Test it quite a lot. To get around SC Linux, either wait before execution starts for doing it in boot, set and force 0 something, to the degree you have to, put it back. And then just inject it, or use LDOSO preload. Questions? Yes?
So your malware ended up loading in a lot of processes, so would you end up getting so many callbacks?
If you don't protect for... Oh, sorry. So the question was, I loaded into a lot of processes. How do I not get a lot of callbacks? And the answer is, after about my 100th callback, I learned to check for PID1 at the top of my library. So that's how. Any other questions? That was not a question. All right. In anticipation of a question, I have 2 lists for the defenders to how to defend against it. Number 1, you could rework the kernel to not allow all these things. You could not let bad guys get root, and that really is the only way. Once you get root, if you have any super critical things, you can use OpenBSD's sort of security-ish functions to prevent a lot of this. If you have the luxury of saying, hey, we need a BSD box, and we're going to rewrite all our code. But it is a pretty good way to do it if you have that luxury. Detecting it, the logs are noisy, which would also make it a lot harder to find net noise. Watching the network, because the malware is going to have network comms anyway, so that's my 2-minute warning. And then, as we saw, check for map memory segments. Anyways, thank you all for coming. Appreciate it this early in the morning.